Right. Sebelum saya go to the next example, I just want to show you there's actually sedikit mistake. This is actually the dew point and this is the bubble point. Okay. Tadi terbalik. Right. Now another one that we look at is actually the K value. Okay, K value. Actually quite simple lah. Sebenarnya K value is just a correlation where we define it as a ratio. Okay, a ratio of vapor and liquid phase equilibrium. Okay, so if it's greater than 1, means that it favors the vapor phase. Okay, so it's easier to turn into vapor. Kalau K1 or Ki is less than 1, it will favor the liquid phase ataupun the concentration of liquid could be higher. Maksudnya dia lebih heavy. Alright, heavy in the sense that dia lagi banyak liquid lah. Yeah? So using the K, kita boleh eliminate lah X dengan Y. Alright, so instead of kita kena kira both X and Y, we just use another correlation, which is K correlation lah. So from this correlation, okay, from this you can get kalau you check balik equation 10.1, okay, so equation 10.1 you akan become K value for the Raoult's law will be Pi set over P, okay, from 10.1. Okay, basically we replace X y1 over x1. Okay, so we put it in terms of K. And similarly the Raoult's law also you get like this. Okay, so the superscript tu mewakili K value lah. So for this we know that since the summation of y, okay, is 1, right? So kita boleh kata the summation of Ki xi will be equals to 1. Okay, which means that can be used for bubble point calculation. So as long as you know your xi, right, you can find K value that satisfy this equation. Okay, and you can also write, okay, this is in terms of x. Another way is you can also write terbalikkan dia. So you akan dapat y1 over Ki over Ki is equal to 1. Okay, so this you use for dew point calculation. So basically this is when you get either you are given one x or K. Alright, you can calculate for bubble point and also for dew point. Okay, so this is another way of solving, right? This is another way of solving. So instead of using the Raoult's law yang panjang-panjang tadi, we can also use K value. It's just an alternative way. But when you want to use the K value, you have to use the chart. Okay. So if you look at the example, right, the mixture of 10% methane, 20 mole percent ethane, and 70 mole percent propane at 10 degrees C, determine the dew point pressure and the bubble point pressure where the K values are given in the figure. Okay. Yeah, this is the figure. So you have to, this is already given, means that the K value already calculated and given in the figure. Okay, very small here, it's very difficult for me to show, but I hope you can see from the textbook too. So what you have to do is basically sort of like try and error. Okay, you have to sort of try and error, because you know that, for example, for dew point calculation, this is the equation. So you have to find, you are given the K, you know the K from the Brewster chart. Okay, so you need to find what is the composition. Okay, so it's basically sort of like the trial and error. Okay. Try and error until you get this equal to 1. So you try at 6.9 bar, you get your y, this is given lah. Okay, you get your p, and then you get your k, right? So you get this. Then you try again, you get 1.17. So you know that it is actually in between these two. Okay, so you try again, you get y over k is equal to 1. Okay. There's another way. If you use Excel, is what we call goal seek. Alright, but the problem is that the equation is not linear, because the graph is not linear. So most of the time this will not work. Yeah, so we have to still do try and error based on the twisted chart. So similarly, when you want to calculate the bubble point pressure, so you find a pressure, okay, based on the given value. So you find K, right? You find at P equals to 26.2 bar. You just try an error, so you get this one. Okay, so you find another value, okay, 7.6, and you get 0.963. So you know that this value is in between. So it should be something like this. Tapi you tak boleh guna interpolation lah, because as I said, it's not linear, right? So only try and error. So there are the drawbacks lah. In terms of calculation, it's easy, but in terms of doing this, not that easy. Mungkin lebih baik you guna round as well, but there are just two ways of doing it lah. Alright, tengoklah macam mana, apa yang saya akan berikan soalan exam ataupun macam mana. Okay, right, now we move on to flash calculation. Okay, so lagi 7 minit. We use flash calculation because we want to sort of like separate lah, partially evaporate. Kita usually flash ni kadang-kadang kita buat flash before kita betul-betul distillate. So we can do that. So kadang-kadang kita boleh buat flash distillation saja, maknanya tak ada distillate terus flash, depending. Okay, so but basically what happen is that you have satu mixture, okay, that you want to separate them and turn into vapor and liquid. Okay, so the sort of like the lighter one akan jadi vapor. Okay, so in this case kita akan only consider the pressure and temperature of the flash, which akan menentukan the calculation, the composition lah, nanti. Okay, so we know that at any point where P is less than this bubble point pressure, it will become vapor. And if P is greater than bubble point pressure, it will become liquid. Okay. So overall balance will be L plus V, liquid plus vapor, will be equal to 1. Species valence, when you have a species lah, depends on how many species you have. So kita gunakan, in this case, we try to replace the L with 1 minus V, ataupun volume untuk vapor. Okay, kita ada satu lagi iaitu Z, mole. So from this, okay, by using the K value tadi, okay, we know that X is equal to Y over K. Okay, kita play around dengan this equation. So put that in this equation. So I'm not, in terms of the derivation, for the online classes, for this semester, since kita banyak buat online classes, saya rasa derivation will not be ditekankan, because if I ask you questions on derivation, you guys can easily look from the book kan. So kalau saya bagi, last time saya fikir untuk bagi soalan dalam in terms of derivation, because ingat tak masa sempat saya ajar dalam kelas, saya buat satu derivation yang agak panjang. I use all the 4 blackboards kan. But then when we use online, I think there's no point for me to ask you to do derivation because you can easily copy. So saya pilih untuk tidak mahu really tekankan untuk you guys hafal the derivation, but as long as you know how to get it, ataupun bila exam pun you tahu kat mana nak cari, that would be enough lah. Okay, so basically we got this. Okay, and lastly you get this, right? So lastly you get this. So we look at example 10.5. Okay, I have only 4 minutes. You are given P1 set, P2 set, and P3 set. So sekarang ada 3. So soalan dia kata apa? Determine L, V, X, I, and Y, I. Okay, so kita first dia kata how to do it. Kita buat bubble point calculation dulu, bubble pressure calculation. And then kita determine the pressure of the bubble point lah. Okay, so the pressure of the bubble, okay, bergantung kepada the composition tadi. So kita dapat 132.4 kilopascal. Okay, and then kita buat due point pressure calculation with Z is equal to X. Y. Okay, to find P due. So by using equation 10.3 sama juga, kita akan dapat 101.52 kilopascal. Okay, straight to the point now, yeah. Just application. You only have 3 more minutes. So we know that since P bubble adalah 132, P due adalah 101, and the given pressure is 110. Okay, so it lies between the bubble point and the dew point. It's not more than the bubble point, it's not less than the dew point. So kita kata under the assumption of Raoult law, kita boleh gunakan balik tadi yang kita dah determine tadi, yang kita dah kata okay, kalau Raoult law dia kata macam ni, so kita boleh gunakan the K value. So you can just find your K value point lah. So for each system, each component, system. So bila kita kirakan balik flash calculation daripada equation 10.17 tadi, okay, equation 10.17, masukkan je balik semua value tu tadi, and you akan dapat V is equal to 0.7364. Now, how to get V? Sebab ada banyak cara lah. Ya, you boleh guna try and error, you boleh solve dia jugalah. Okay, so bila solve tu, you mungkin akan dapat beberapa value of V. So find the value of V yang logic. Okay, yang logic. So the logical one is 0.7364. And so sama juga kita dapat liquid will be 1 minus V, so kita dapat 0.2636 mole. Okay, this is in mole. Okay, 30 seconds. So, and then you can solve for Y1 and X1, and then that's it lah. Okay, yang ni saya rasa boleh cuba buat sendiri sebab saya tak cukup masa untuk ini.